All right, let's get right into it. Welcome to this explainer. Today, we're tearing down the mechanics of how we can finally bridge those incredibly complex, totally disconnected factory floor protocols. We're unpacking Google Cloud's Manufacturing Connect Edge, you'll often hear us call it MCE, and we're looking at exactly how it translates legacy systems like Siemens S7 and Modbus straight into modern unified data streams. Okay, let's dive into this, because the answer to the question on this slide usually surprises people. When we think about deploying AI in a manufacturing setting, we tend to assume the absolute hardest part is the machine learning itself, right? Training the models, securing the massive compute power, or fine-tuning the algorithms. But actually, the AI itself isn't the primary bottleneck. No, the real barrier sits much, much closer to the ground. Section 1, the Factory Tower of Babel, Overcoming OT Fragmentation. If you walk across any high-speed, multi-vendor factory floor today, it is literally a Tower of Babel. You've got legacy Siemens PLCs sitting right next to simple Modbus sensors, and they're all operating right alongside Allen Bradley controllers and modern OPC UA gateways. You have all these competing status lights flashing at you, but these devices are completely disconnected from one another. Every single machine vendor speaks a totally different language. And because of this massive fragmentation in legacy operational technology, or OT, your critical sensor telemetry is basically locked away in isolated silos. The data is absolutely there, but it's trapped. Section 2, MC, the Universal Translator, Unifying Factory Ingestion. Enter Google Cloud's Manufacturing Connect Edge, or MCE. You can really think of MCE as the ultimate factory floor interpreter. It operates right there on a modern industrial gateway, connecting directly to the physical PLCs at the OT layer. So instead of leaving you stranded trying to figure out what to do with all that chaotic raw register data, MCE standardizes it. It takes those raw streams, whether they're coming from OPC UA, Modbus TCP, Siemens S7, or Ethernet/IP, and converges them into clean, structured payload formats, specifically a unified, normalized JSON stream. Now, what's really interesting about this slide is the sheer scale of that translation capability, 270 plus. That's the massive volume of different industrial protocols that MC can act as a universal translator for, right out of the box. You aren't just bridging one or two legacy systems here. You're equipped to handle virtually the entire spectrum of industrial communication protocols. It's a real game changer. So the actual workflow happening on that edge gateway is a seamless three-step ingestion process. First, MCLA makes a direct physical connection to the PLCs. Second, it does the heavy lifting, translating all that complex, raw register data. And third, it outputs that beautifully clean, normalized JSON stream. The chaos of the multi-vendor factory floor is instantly organized before the data ever even leaves the building. Section 3, Seamless OT to Cloud Data Flow, Decoupling Ingestion from Protocol. Let's trace the exact journey of our newly unified data stream as it moves from the factory floor all the way up to the cloud. That normalized telemetry flows seamlessly out of MCE and is instantly routed into Google Cloud PubSub. From there, it passes right through Dataflow and finally lands directly in the Manufacturing Data Engine, or MDE. It's just a straight, uninhibited pipeline built specifically for the standardized telemetry. So the crucial point is that this entire journey, from the physical PLC through the MCU translation and up through the Google Cloud pipeline, happens in real time. We are talking sub-second latency here. It's near instantaneous data availability from the OT layer straight into the cloud. And here's why this decoupled architecture absolutely matters to your operations. By separating the messy, raw protocol handling from the actual cloud ingestion, your cloud tools are completely protected from the factory floor chaos. Honestly, whether a temperature sensor is speaking Modbus or an advanced machine is using OPC UA, tools like BigQuery and Vertex AI just receive perfect, clean, standardized data models. And the absolute best part? It feeds these advanced cloud AI systems seamlessly, requiring exactly zero custom pipeline code on your end. The whole shebang is just taken care of. Section 4, Unlocking Closed-Loop Industrial AI Beyond One-Way Collection. If we contrast the legacy standard with the MCA advantage, a massive structural shift becomes super clear. We're finally moving away from the old paradigm of one-way data collection, where you simply pull data from the machines just to passively watch it on dashboards. Instead, we unlock the true power of MCA, which is bi-directional control. It isn't just about collecting data anymore. It's about pushing instructions back down to the floor. And this brilliantly illustrates how that bi-directional capability actually works in practice. Yes, sure, your real-time machine dashboards are updating instantly with that sub-second latency we talked about. But simultaneously, your cloud-trained models in Vertex AI can analyze that data and push optimization commands directly back through MCA to the shop floor. The PLCs receive these commands and adjust automatically. So, for example, instantly modifying an OPC UA motor speed controller based on a real-time cloud calculation, the AI is actually talking back to the machinery. As the source material highlights, this achieves something incredible, unlocking full, closed-loop automation across legacy plants. Really, this is the ultimate industrial ROI. You are taking legacy hardware that speaks outdated, fragmented languages and bridging it directly into modern, bidirectional AI capabilities. You finally close the loop between observation and automated physical action, and you do it without having to rip and replace your entire factory floor. All right, thank you for joining me for this explainer today. I hope this deep dive into MCE protocol translation helped clear things up, which leaves us with one final thought as we wrap up. Now that the biggest barrier to industrial AI has been completely removed, and those legacy silos are finally broken down into a unified bidirectional stream, what will your factory floor automate first?